At a time going over the in-class problem and the other problems that have to do with some basic stoichiometry issues. So I have my calculator pulled up. I have my stoichiometry questions. So let's get started. Okay. So the reaction that we're dealing with is solid aluminum chloride, and it decomposes into its elements. This question, this reaction, or this statement is has a lot of information plopped into it. And so the first thing is that we are dealing with aluminum and chlorine, and it then decomposes. So that means that it reacts to form, and then we don't know what it forms except it's going to react and decompose into its elements. So it's going to form aluminum plus chlorine. Okay, so that tells us kind of what's going on. Now, what we need to do is make sure that we have the right formula for all the parts of the reaction. And we do that by remembering how to write, in this case, ionic compounds. And so aluminum, remember, is a 3+ charge. Chlorine is a minus. The least common multiple is a 3, so we need one of those and 3 of those. Okay. Now, this is aluminum. Aluminum is a solid, and then chlorine, Cl2, we find chlorine as a gas, and it's diatomic. So the chemical equation for this is AlCl3 reacts to form Al plus Cl2. Now, I'm going to put states in, okay, because that's what the question is asking for. Let me move this, see? So it's states. And we need to balance this guy. So there's a lot going on here still. Okay, so I'll put states. I'll put states in red. So this is solid. A couple of ways you can tell is, first of all, this is an ionic compound. Ionic compounds are always found as solids. Secondly, if you notice here, it says solid aluminum chloride. Don't underestimate the power of answers being given to you in the question. And then we know that aluminum element, aluminum is a metal, so that's a solid. And then chlorine is a gas on the periodic table. And now we have to balance, so we're going to balance this in blue. And when we balance, let's see, so aluminum and aluminum balance, there's one each. And so now chlorine is Cl3, this is Cl2, so you can do this one of two ways. I'm going to do this way, because 1.5 times 2 is 3, but now we have to multiply everything by 2 in order to get rid of the half. Okay, this half we can get rid of, so we get 2AlCl3 solid reacts to form 2Al solid plus 3Cl2 gas. And that is that's the first one done. And then it says determine how much of each product is made in moles. Okay, well, this is where we're going to have to do an ICE chart. Okay, so we're going to go ICE. And we have 8.91 grams of aluminum chloride. So outside here, I'm going to put 8.91 grams because we have 8.91 grams of this. Now, below my ICE chart, I'm going to put my work. So here I have AlCl3, and keep in mind that whenever you put numbers into an ICE chart, that's a stoichiometry ICE chart, you have to convert them to moles. That's actually rule number 1, convert to moles. So here, grams, we can't put grams in here. We have to convert that to moles. Well, how do we convert grams to moles? We have to use molar mass. So the molar mass of AlCl3, we pull out a periodic table, and we know that aluminum is somewhere around 27, and there's one of them in the formula. And then chlorine is 34, 35.45, and then there's 3 of them in the formula, and then we're going to add that up. So I'm going to turn on my calculator, get rid of some of that, wherever that work came from. Okay, and then I'm going to do 27 times 1 plus 35.45 times 3. Okay, and that gives us the molar mass of somewhere around 133.35. Now, I suggest that whenever you calculate the molar mass here, that you use the periodic table, and you report these masses out to as many significant figures as your periodic table gives you. Okay, I'm just kind of rounding the numbers because it makes it a little easier for me to do this right here. But now we're going to take 8.91 grams. We have to X-line this guy, and we're going to go grams. Oh, you know what? I got ahead of myself. That can happen. Okay, it's 8.91 grams of AlCl3, and we're going to X-line this, and I always use the units first, so this is grams to moles, and so now we're going to use the molar mass. For every 1 mole, there's 133.35 grams. So, to find the moles of this, to find out how many moles of this, you get 8.91, and then divided by 133.35. And so you get 0.0668 moles. Keep in mind sig figs. There's 3 sig figs here, so we're going to do 3 sig figs. So the answer here is 0.0668. Now, let's go on. So this is going to go down to 0. At the end, we're not going to have any of this left over. It's all going to react away. So now this is going to be minus 0.0668 because we're going to subtract as much of it as it will allow. Now, let's go over to the other side. We're going to start with 0 of each of the products. And I say this for a couple of reasons. First of all, we do the reaction because we want to form the products. Okay, so if we had any of the products to begin with, we probably wouldn't be doing the reaction like in real life. Secondly, notice that the only information that we're given is about aluminum chloride. It doesn't say anything about having any aluminum or any chlorine gas in the problem. So if it doesn't give you the information, we have to assume that these are 0. Okay? Now, here's the thing, is based on this change box right here, this value, okay, and I get that these two are the same, but they're not always going to be the same, but based on this change box right here, we can calculate the rest of the values in the ICE chart. So now, we do this by using, again, X-line, but we have to use the balanced chemical equation. So, just kind of as a mental note, this is a separate calculation. So what I know is I have to go 0.0668 moles of AlCl3 used up. And then we're going to X-line it. And now we want to get rid of, instead of moles here, we want to get rid of AlCl3, and we want to convert that to aluminum. And in order to do that, it's a 2-to-2 ratio. We're going to use the balanced chemical equation. Okay? So we use the coefficients of aluminum and the coefficient of aluminum chloride. So we do this, we cross off AlCl3, and notice what we have left. We have moles of aluminum. Now, I don't need the calculator to do this math because 2 times 2 is 1, so this is going to be 0.0668 moles. But in this case, we converted it to moles of aluminum. So we're going to go 0.0668, but because this is a product, we are making it, so it's going to be plus 0.0668. And now we can do this box. We're still going to use this red one to go here, but instead of going from AlCl3 to aluminum, we're going to go from AlCl3 to Cl2. So we're going to go 0.0668 moles of AlCl3 times, then we're going to X-line, we're going to go from AlCl3 to Cl2, and now that's a 3 to 2. Again, looking at the balanced chemical equation, I have 2 AlCl3 and then 3 Cl2. So I use those coefficients there. This cancels out, and so we're left with moles of Cl2. So that's pretty cool. Okay, so now we go 0.0668 times 3 divided by 2. Orders of operations, they matter, but multiplication and division have the same order. So this is going to be 0.100 moles of Cl2. I do that because we want to carry on significant figures. So this is going to be plus 0.100. Now these two boxes are pretty straightforward. 0 plus this is 0.0668. 0 plus 0.1 is 0.100, again, keeping in mind sig figs. And so that answers question B, how many moles? And then it says how many grams are produced. And so now we have to take and convert moles to grams. Well, how do we convert moles to grams? We have to use the molar mass. So put my little line here because I'm going to separate my calculations. And so we have to X-line, and we go from moles to mass, again, using the molar mass. Molar mass converts between moles and mass. So 0.0668 moles of aluminum, right? I got that from, well, it's behind the calculator, but right there. Okay. Now we're going to X-line it. And we're going to, now what are we trying to get rid of? We're trying to get rid of moles. So we're going to put that on the bottom. And we're going to put grams at the top. And remember that aluminum was 27 grams per mole. So we're going to take 0.0668 times 27. And we're going to do 1.80 grams of aluminum. Okay, moles cancel. We're left with grams of aluminum. We do that math. Okay, now we do the same thing for chlorine, Cl2. Okay, Cl2 is 0.100 moles of Cl2. We X-line it, and so chlorine has a molar mass of 70.9, and that's grams for every 1 mole. Okay, moles cancel. We're left with grams of chlorine, and so that is 7.09 grams of Cl2. So now we can go up here, and even though it's not part of the ICE chart, what I can do is I can take this and I can go, this was 1.80 grams, and this was 7.09 grams. Now there's a check, and the check is to compare how many grams we started with. Because of the law of conservation of matter, that number of grams that we started with should be very, very similar to the number of grams that we ended with. So initially we had 8.91 grams, and at the end we have 1.80 grams plus 7.09 grams, which equals 8.89 grams. Now I know that those two are not exact, but in chemistry that's close enough, so that's a check. Okay, so that's how you're going to solve these ICE charts. Okay, have a great day.